Hello, everybody. Welcome to the joy of coding. Our 10th episode. That's pretty exciting. 10 episodes in, we're still doing this, so things must be going all right. Um, let's get started because this is kind of going to be a short episode today, and I apologize about that, and I'll get into it in a second. So, this is our agenda. If you go down to the comments of the Air Mozilla page that you're on, if you're watching this on Air Mozilla, there's a link to this live document that allows you to see the agenda. So first thing is there's no camera today. There were some delays with it, some weird sync up issues, so you don't get to see my sweet new haircut. If you want to talk, we are in #live hacking on irc.mozilla.org. If IRC is a thing that you like, there's a handy link to a web-based IRC client in the Air Mozilla page that you're viewing this on, if in case you want to use that. We have logs now. If you're interested in reading the chat logs in that channel, we have logs now, and we are logging activity in that channel. Again, I have to cut today's episode a little bit short because of a meeting that was scheduled in at 2:30, so I only get to do 1.5 hours today, so let's try and get started ASAP. So we are getting back to view source. Where did we get to last time? We got to the point where we were able to load the view source window, and the view source window opened, and if we were opening the source from a remote browser, then the browser in the view source window would also be remote. And we sent down a message with the outer window ID, because we landed a patch to do that last week, and with that outer window ID, it was, I believe, able to get a page descriptor, or basically a BF cache entry or session history entry for the document that was loaded, and we were able to view the source with that. Unfortunately, it looked like we were still loading the source off of the network, so I wasn't sure what was going on, and that's more or less where we left it. I have not done any work on this since, so let's keep going. Yeah, that's this note. One thing I did notice, however, so this is the note. If you go back to the agenda, there's a link to this note as well. First thing, I thought this was kind of funny. This is a GIF illustrating what it's like to work on this bug, where you're trying to do this nice separation, and what you end up with is a little bit of a mess if you're not careful. This is what would go. This is the worst case scenario, so let's not let that happen. There's also another bug to keep an eye on while we work on this bug. That's bug 1067325, which will allow us to open the source of a page in a tab. It's an option. So someone else is kind of tromping around in the view source code, and we have to keep an eye on that and make sure that we don't either duplicate effort or invalidate each other or do things that basically make both of our lives hard. So keeping an eye on that bug. I have kind of an advantage because the fellow working on this bug is on PTO until the day after tomorrow. So whatever we get done, if we land anything between now and the 17th, or next Monday, because he's unlikely to be working on the weekend, then he gets to work off of that. It's a little bit of a race, but not too much of a race. So here's where we are. Find out why we're still hitting the network. So let me demonstrate us hitting the network. I already have rebased our patches from last week on top of tip, a recent tip. This is just, I think, the day before yesterday or something. No, yesterday. It was today. I pulled this morning. So we need to, I'm going to demonstrate us hitting the network again. So I will open up the browser. The page that I used to test, I should really bookmark it now that I think about it, is this like page that spits out poetry after a post request, and I'm going to bookmark it. Bookmark animation, and I'm going to call this one view source test. That's what I will tag it with to make it easy to find. So if I hit groove, I get this stuff, and in the best case scenario, this is what, like in the working scenario, this text is what I should see in the view source, because we shouldn't be reloading off of the network again. But when I load view source, I get something completely different. So why is that? That's the question. So I did 2 builds to try and save us some time. I did a debug build and a regular build. We were just doing an opt build right now, and like we were just running an opt build. We're probably going to end up needing to use the debug build and Xcode in order to figure out what's going wrong here. The first thing I'm going to do is I'm going to run that same experiment using a debug build, and I'm going to see if there's any useful log spew or console spew. And now, if you've ever used a debug build before, you'll know that there's always a ton of console spew, and sometimes it's like a bunch of warnings and errors and stuff that probably shouldn't be in there, but it's kind of a losing battle trying to get rid of them. Um, Oftentimes it's just us reporting things going wrong, even though there are backup plans. Like sometimes there are expected or handled failures, but we still log them, and that's where a lot of like this stuff comes from, like the warnings and whatnot. So now I want to find out if, whenever I view source, there's anything in the console spew that like draws my attention to give me a sense of maybe where I should look. So what I'll do is so I've actually got this page here. So I've got this stuff, and now I'm going to like create a block. I'm separating so that it's easier for me to determine which stuff is fired after I view source. And now I open view source, and a bunch of stuff comes up. What? So that's interesting. We actually were able to get the source for this page. Okay, so what just happened was, in this debug build, it looks like we actually did the right thing. Now, something to keep in mind is that we retrieved this document, I think, out of the session store. So before I do anything, I want to confirm the behavior that I think we're supposed to have. I'm going to open up a non-ETNS window. I'm going to go to this page, and horrid lacerations. I'm going to view source. So that worked. Now what if I, instead of, that's without the post. So how about with the post request? So if I groove, so I get this not all well, I will listen to you, etc., etc., and when I view the source, okay, so this is what we should get. This is the test case, and it works in non-ETNS. So let's redo the test case. Or hold on, go back, groove, so I think that's an I'd have grew, and then load the source. And right, so it is indeed busted, and and all of the separation I did before is kind of for naught, because we did a bunch of activity in between there and then. So let me try that again. I will go back. Don't tell me the back button is busted again. No. No, what are you doing? Oh, well, you know, opening up the back button like pop-up to show all of the like entries is actually oh, when I crashed the content process. Very interesting. That's what happened. Because of why? I failed an assertion somewhere in the compositor? Somewhere in graphics. I'm going to ignore that for now as something that's probably not my fault. So let's not lose track. Let's not get distracted. And let's reload here. I mean, that's what it's like using nightly software, and particularly a debug build that has a whole bunch of runtime asserts that in a debug build, asserts will, if you don't satisfy the assertion, we crash the process. So that's not too surprising. So the experiment again, I will separate, I will hit groove, and then I will view the source. Actually, let me do more separation, view the source, and then let's see what we get. So does anything in here draw my eye? So this is, we have this log message in there for when we load the page, and then we have this ns ensure true is file URI failure here. So I wonder if somehow that's related. What is this? So this is our first potential clue. It might be a red herring. Let's see what this line of code is supposed to do. So third-party util lines 368. And I have a bunch of other source code open from another bug I'm working on. Sorry about that. So here is, we get the base domain for a host URI. We fail this. We fail here because the URI apparently doesn't have a host. So what is the URI in this case? So let's see if we can figure out what the URI is in this case if we hit this code again. So we will, I'm going to attach my debugger on the child process. That's 77801. Close this. Oh, another thing I should check is it reproducible? Like if it doesn't do it again. Wait, which window do I want? So many terminals. All right, I'm gonna quit this one. I think we want this one. And apparently the content process died again. I wonder if, like I said before that it's not my fault, but it actually might be. It looks like the content process is crashing after I close the view source window. So I wonder if maybe something in how I'm tearing down is busted. So that's a thing to investigate. I will add it to that will maybe be the next thing we figure out. Am I causing a crash when we close the view source window? And let's get the stack in there for later. But let's not get distracted by that right now. This is the thing I want to know. So do I hit that again? Do I hit it reliably whenever I view the source? Let's find out. If anyone has any theories about this bug, by the way, I'm happy to entertain them. I'm happy to hear about it in live hacking in the IRC channel, and maybe you can give me some pointers. Who knows? Maybe you're watching from afar going, I know what the problem is. In which case, I am begging you, let me know, save me some time, and then we can like celebrate your genius in finding the problem. So we're back in the state where we want to run the test. So I'll create some separation, load view source. And yeah, we do hit it again. So this seems to be pretty consistent. Now I'm going to, as an investigation for the crash, let's see if we crash if I just keep it open. Let's just keep it open for a while, not do anything, while we investigate. And then later I'm going to close this window and see if we crash soon after. Because it's probably like something, I'll bet the crash is related to garbage collection or something. Maybe we try to free something that's already been freed or something like that. Or read into something that was erroneously nulled out or something along those lines. So what I want to do is, to investigate this bit, I want to attach to the, oh, you know what? Am I able to open a second view source? I am. Okay, so I don't have to like I seem to hit it consistently as well, I think. This third-party util thing. So if the close of the window is really crashing the content process, I'm not going to close either of these two view source windows I just opened up, because that would change the process number. So instead, I will keep them open. And I will attach my debugger to the content process. And while I think about it, I'm going to make sure I don't go over time by setting an alarm on my phone. One sec. So I'm going to give myself like a 3-minute warning. Cool. Okay, so we are attached to the content process. I will set a breakpoint now. Where was it? Third-party util, and is this namespaced? Probably. I find it's easiest to look inside the header to figure out namespacing. Wow, it doesn't appear to be namespaced, so it's just third-party util, and then I guess actually I want to do it by line, so I don't even need the symbol. I just need the line number. So 368. So that's over here. Break third-party util.cpp 368. Great. Continue, and let's hit it again. So open up the view source window. Boom, hit our breakpoint. Xcode fires up. And I believe we've got some JS on the stack. This is probably the code in our frame script that's attempting to load the page. So let's make sure. We'll dump the JS stack. View source content. Yeah, I'm gonna say I have a high degree of confidence. View source content that load page is where we are at in the JavaScript. Yeah, it's right here. We call load page, and what are we passing in? We have an SH entry. Yep. And with load history, I guess. So we must have gone through here, I assume, because this code is supposed to be executed if display type, where display type is display as source, and what is display as source set at? If it's 1, then everything is hunky-dory. Yeah, it's 1. Display as source, so we must have executed this stuff. So now we have this like URI. Old URI. What did we do here? We tried to get the old URI, and then we attempted to append view source to the new URI, and then append the spec. The spec. What's spec? Spec is, oh, just get the spec from there. And then we tried to create a new URI. And then we set the URI in the shell, the session history entry. I always, for some reason, think that SH stands for shell, but it actually stands for session history entry to the new URI. So the SH entry should have a URI that hopefully we could look at. Interesting. It doesn't. It starts with an H, not a V. So that's neat. I would have thought that it would have started with a V if this was supposed to be replacing the URI view source. But it apparently starts with an H. Let's take a look at the memory. I can't. There's nothing there. What if I view the memory of mdata? I don't know why that doesn't work sometimes. I just want to view the memory. Let me see the memory. And it's just pointing me at null. Alright. Well, Maybe I should set a breakpoint here as well for next time and figure out what's going on in here. But meanwhile, let's keep going up the stack. So we were in here, and then we said load history entry. So we have a base URI here in this internal load. We're somewhere in doc shell. Oh, hey, we don't have a URI. That's interesting. So URI was not passed, or no, hang on. Where does it get the URI? Base URI, base URI, base URI. Get base URI from the entry. So this is another interesting bit of code. Is source doc entry? What is that supposed to mean? Get is source doc entry. Is that a view source entry? M is source doc entry. Set source doc data. What even is this? Let's take a look at the IDL for NSISH entry to see if there's some documentation. Source. Okay, when is source doc entry is true, this contains the base URI of the source doc document for use in situations where it cannot otherwise be determined. For example, with view source. Contents of the source doc attribute in the source doc iframe to be loaded instead of the URI. Similar to a data URI, this information is needed to recreate the document at a later stage. Is true if this SH entry corresponds to a document created by a source doc iframe. So that doesn't tell me too much. I don't really know what a source doc iframe is. Let's go to the internet and ask. Source doc. The content of the page, the embedded context is to contain. This attribute is expected to be used together with sandbox seamless attributes. Browser supports the source doc attribute. It will override the content specified in source. So let's see an example of it being used. It's actually, this looks pretty new. Firefox 25. Source doc. And we will look at the bug where they implemented it, because maybe there are some tests. And if there are tests, I can see how it's supposed to be used. Tests! Hey, lovely. Okay. So you can actually put the source of the page as a string into the source doc attribute. I did not know that. This is new information to me. I have fallen behind. Okay. Well, now that we know how that works, I'm going to add that to the things I've learned this week. I have this list of things I've learned, and source doc attribute. I won't just keep that added to my list. But let's not get distracted. Let's keep going. So the source doc attribute, it doesn't. So the iframe that we're loading is actually a browser. It's not an iframe. It's a browser. Although under the hood, I think Gecko kind of equates an iframe as a sort of a simple browser. And this should be false because we're definitely not doing anything with the source doc stuff. And so we've eliminated source doc as something that we kind of have to worry about, I think. So back to our debugger. If it was a source doc, then we get the base URI. But because we don't have source doc as true, source doc is false, yeah, then that makes sense. So that was a sort of a roundabout exploration, but we realized that everything is kind of working as expected. So, internal load. Now we're here in the stack, and we're loading some URI. What is a URI in this case? It's probably that URI that has It starts with H. I thought it was supposed to start with V for view source. Um, maybe that's the problem. I don't. So let me write that down. Let me write that down. So down here, hypothesis. So I have to test this hypothesis, and the problem I saw was over here in ns.shell load page. We are not prefixing the URI with view source as we should be. So I have to test that hypothesis. Who knows? That might be the root of my problem here, and then if I can solve it, then we're good to go. That might be it. Who knows? But let's continue on and just see what's going on in here. So do URI load is called, which opens a channel, I guess, to hit the network. And we're opening a channel, so there's a lot of architecture here. We have a URI loader from which we pass it a channel, for which we pass it a channel. The URI loader has like some stuff on it, and we pass some flags, and we pass it the network channel, I guess. And then it opens the URI asynchronously. And then is third-party channel. Check the window hierarchy. This covers most cases for an ordinary page load from the location bar. So, where are we here? Is third-party channel. I guess a third-party channel, maybe it's something like if someone has added a protocol? Is that what that means? Like if someone, some add-on has added a protocol to Firefox, like Gopher or something. And we get the base domain of the current URI. And what do we do? When we try and get the base domain, we fail this case and then we return false. Or sorry, don't return false, we return the failure result. And then what happens up here if we had returned the failure result? If we failed, then we couldn't compute whether this is a third-party load, and we assume that it is. So that's one of those failures that we handle. Okay. What about view source? Okay, you know what? Let's continue. What I'm gonna do next is see what happens in the good case. Like we've seen the failure case. Actually, no. Before we do that, let's just quickly, because I'm curious, let's hit that other breakpoint that I had set up here and see what goes on in here. Like, are we actually setting the URI correctly? So we get a URI. The old URI is now this NSI URI, and then we get the spec. The spec is now the string that is of length 44, starts with H. H. Why would it start with H? Oh, probably because when you view source something, you still include the protocol? Yeah. Okay, that's fine. So then on the new spec, so far we've got this view source, and then we append the spec, and then so new spec should be the old, like view source colon plus the URI, the old URI. That looks right. It starts with V, and then we attempt to set the URI. Now let's see what happens in here. We have to kind of drill past some xpcom group. set URI, blah, 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 abstract, abstract. I'm just drilling down into the set URI. And then we set MURI to AURI. And AURI is what we were passed in. And the path, wait, AURI scheme starts with V. Okay, that's good. So maybe I was getting distracted by the wrong thing, because I was worried that the SH entry had the wrong URI, but maybe I was looking at the wrong part. URI, if I look at the, I guess I can't really inspect it. Can't really look at it. But it looks like MURI kind of did the right thing. So maybe I shouldn't be as worried. So now my question is, do I hit this in the non-ETNS working case as well? Because if so, then this whole thing is a wild goose chase. So let's connect to the parent process. The parent process is there. I will attach the debugger there. I'm going to continue this load there. And then here, this is where I'm going to set the breakpoint again. Yes. So now, if I open this in a non-ETNS window, or wait, I should open this link in the non-ETNS window and do a link location, and then do the request again. Okay, groove, and now let's view the source and hit the breakpoint. Huh? So yeah, the parent process. Oh, that's neat. I'm glad that the breakpoints are shared between the two processes. I did not know that about Xcode, so that's good. So play through. And yeah, okay. So this was a wild goose chase. We always hit this. This is being hit in the good case as well. Yeah. So that doesn't help us. So that was a wild goose chase. So this hypothesis about not prefixing the URI with view sources we should be, this is false. We were indeed. And it looks like that ns ensure true is file URI warning is a wild goose chase. We hit that in the parent process as well when viewing the source in a non-ETNS window, which works properly. Okay, so we still have not figured this out. Well, we were in kind of the right place, though. I mean, we got that stack, and at some point, the SH entry is used, or it's the we retrieve stuff from the cache instead of the network. And I'd like to find out where that occurs. So let me do that again. This is again in a non-ETNS window. Hit my breakpoint, and then let's just kind of walk through and see what happens. Let's do all that good stuff. Then we're loading from the history. Now, like, this is, to me, what I want to pay attention to. This is what we're doing to tell the, I guess, doc shell that we should be loading from the cache. And I don't know what other values that can take. But whatever pays attention to that is worth paying attention to. So drill past some xpcom group. Okay. Then what? We go through this stuff. We ensure a bunch of success in places. Do all that. Now what's paying attention to that second argument? Load type, load type. We should fail this conditional because the scheme is not JavaScript. So we should skip this block. The load type is not load command reload. So flags are internal, load, flags none. Do not inherit owner from document. It's pretty important, it sounds like. Okay, and then we are not a source doc entry, so that's expected. We should skip that. So the source doc is the null string. And so that argument, a load type, is now passed to internal load. So let's set a breakpoint in there. I'm worried about, like, sometimes drilling down into something like that takes a while because you have to, like, for each one of them, you have to, like, step into how it's computed. Maybe there's a better way around that, but what I'm going to do is I'm just going to find the internal load method and set a breakpoint in it and then continue until we hit it. Right. We are skipping that stuff. We set. Oh, we don't have doc shell array request set. Um, we do have a URI. We're looking at load type again. Again, we check to see if we're JavaScript. We skip over that. Where do we ever check the view source prefix? That to me is probably what's interesting. Script global, get frame, element internal. I don't think that matters. Some kind of MMA death grip. Okay. I don't know why it's called that. Well, so we have these things called Kung Fu Death Grip, which are just like uh, references that we hold to something to make sure it doesn't go away before we're done dealing with it. We generally call those Kung Fu Death Grip. Someone has decided to call this one MMA Death Grip. That's funny. Okay, we are not creating a new doc shell, maybe? And now we are attempting to locate the document, the doc shell in which we want to load the document. Right. But we skip that whole block because a window target is probably null. So we skip that entire block. Now we're here. Are we a frame? No. So the content type is type document because we don't have a subdocument. We're not a frame. We're not a subframe. We are a browser, a remote browser. BZ asks, would be nice to know, or he says, would be nice to know what the loading principle is in here, but we don't. We create a principal. It's a security thing. Check the load policy. This is interesting. Should load. Oh, you know what? This is probably just to see if we're, like, for add-ons to, or various bits of Firefox to, like, have a load policy. You could have, like, something like ad block preventing particular types of loads, and I think this is where we check load policy. And the content is not blocked, so we skip over that. Load type, it's not that, so we skip over that. All loads that will inherit our security context if this document came from an unsafe channel. Ugh, what are we doing? I think hopefully we don't enter this while loop. Great. Now where are we? Where did we end up? Okay, we ended up just after it. Sorry, I thought we'd already checked a window target and star a window target up here. So it's kind of weird that we check it again, but alright. So we check it again. we're going to skip this block too because those things are still false, probably. Unless they've changed because of stuff. No, they have not changed. So we skip all that. We are not being destroyed. Check permissions. I'm guessing that went well. If we fired the unload event already, that shouldn't have happened. Do some security. If it's opened by a frame loader, make sure to cancel possible frame loader initialization before loading a new page. Sounds like something I should know about. Try cancel frame loader initialization. This dock shell is owned by a frame loader. Yes, this is just to avoid races or something, maybe. Before going any further, vet loads initiated by external programs. We should not be doing that because we're loading from history. So here's where I see some load history. Load history right here. So we should enter this block. Okay. Split current URI and a URI on the hash character so that if the URI has like an anchor at the end of it, we don't look at it, I guess. Same except hashes. So if there were no hashes, I guess. So that should be the case, I think. P, same except hashes. Oh, it's not. I don't remember the source that we're on, but hash equals. Okay, so what is cur before hash? Great, a bunch of. So it's about blank. You can see here. This is the string. This is the null, and this is a bunch of random memory. And then p new before hash. It's view source. So this is where we're attempting to view the source. View source. The site. Okay, so I guess we're just making sure that we're not attempting to load a page that we're already on or something if we're attempting to load from history. Okay. Blah, blah, blah. So this is, we're doing a history load. This is interesting. I hope to get there soon. Because we should have a SH entry. A SH entry that we had passed in. Do we have MOSHE? What is MOSHE? Yeah, we got one of those. So if history nav between same doc. Okay. A short-circuited load happens when we navigate between two SH entries for the same document. We do short-circuited load under two circumstances. I don't think that's what we're doing. I don't think we're doing a short-circuited load. Just to remind you, if you're joining us, if you're just joining us now, we're attempting to figure out how view source works in the good case. And we're drilling in here. So I'm going to do this again in the bad case, hopefully a little bit faster, because I'm a little more familiar with it, and then we'll see what maybe we screw up in the bad case. Check if the web browser Chrome wants the load to proceed. This is something that Mossab added. Should load. Ooh, I wonder if that maybe has something to do with it. We'll see. Then we do a Kung Fu Death Grip. Ah, well, I'm looking for stuff I care about. If we have saved content viewer and hit restore it and show it now, this sounds really important. This like sounds like the thing. PASH entry, and then P M load type and load command history. I believe we should. I'm pretty sure we're going to enter this block. Yep. We get the doc. So this is super important. So we get the doc shell ID. It's possible that the previous viewer of M content viewer is the viewer that will end up in the SH. Close this when we are forcing this to restore it. Don't know what that means. Whatever. Get the previous viewer, if there is one. We do stuff to it. Next, we restore the presentation. If restoring, are we restoring? No. So I thought that was important, but it might not actually. Sync presentation state. And then we actually do the load. So like, what does this even do? Hmm. Okay, well, maybe that wasn't as important as I thought. Load flags is source doc. It's not a source doc, we learned that. Network prediction stuff. Oh, and then we go in down another layer. Do URI load. So where's that? Deep into the guts of DocShell. If DocShell interests you, um, you might enjoy some of the posts on my blog about DocShell because I've been exploring this thing, trying to pick it apart. It's a pretty complicated piece of code, and I'm trying to make sense of it. And it's hard. It is pretty hard. Oh, only allow view source scheme in top-level doc shells. View source is the only scheme to which this applies at the moment due to potential timing attacks to read data from cross-origin iframes. But we're not in a frame, so we skip that. Open channel for the URL. But like, we're loading this out of the cache. Why? Ugh. Maybe we'll get down here. Blah, blah, blah. Blah, blah. Move on, move on, move on. Don't care. We are not a source doc. We create this load info thing. What is this load info thing? Load info. What are you? Load info. I know nothing about load info. Okay. Oh, wait, we haven't finished initializing it. Okay, now what's load info? So we got an inner window ID. Missing a base URI. It's got a principal. Okay. We didn't enter that else. It's not. Oh, it is an app cache channel. Is this where we retrieve it out of the cache? Loads with the correct permissions to check for a matching application cache. So this is something where we only do this in the parent process. That's interesting. Wait, what? Did we just... What is... What? What is this value? Oh, right. So we are in the parent process. Right, okay, this is a not equals. I was wondering why we didn't enter this block. So that's interesting. That's a differentiation between the content process and the parent process. Content type. Oh boy, oh boy. So much pain. And then force cookies if first party set document URI to something. And then do we have props? Nope, no props. This is an HTTP channel, then set up the HTTP specific information. So we do enter that. Get the cache key. Aha, that's important. Another breakpoint. What's the MLSHE and the MOSHE? These definitely need better names. L and O. Session history entries, and then old. I don't know. I don't know, Skip. I don't know what that is for lead reload cases. Now, in this particular case, we were doing a post, so maybe that's why we saw view source working properly when we did a proper like a cache lookup from the session store before when I said it worked. This was after we had done a session restore and not a post, and so this might be the real differentiator right here. So, if m load type equals load history, try and set the cache key. Set load flags. So I think we did this. That's really interesting. Let me set a refer. And then we actually do the channel load. That's where we entered this thing. And I'm just going to continue. And then RV is okay. If the channel load failed, we failed, and SI web progress just ain't going to happen. So then we're done. And we loaded the source. Now let's do it in the bad case. That took a while. I'm sorry for the wait. Let's do it in the bad case. So here we are in the bad case. Now I'm going to fast forward because I set a bunch of breakpoints on things that I think were interesting. Do we do this? We skipped right over it. That's interesting because I'm pretty sure we entered this before. So PASH entry is null. Is null. We need that thing. That's a problem. That's probably why we're not retrieving from the cache, is for some reason ASH entry is null. Because we definitely need that. Let's keep going. Yeah, we didn't enter any of this stuff because we don't have a... well, we didn't enter that stuff. That's really interesting. Let's do that again. Let's see why we don't have an SH entry. Oop. Oh, here we are again. Nope, still don't have it. And we're loading a bunch of documents, it looks like, with never passing the SH entry. Oh, because we're loading a Zool document. Right, we load a Zool document, we load... Okay, now here we go. Now we're entering the right stuff, I think. So this is now the one I want to pay attention to. We should have an SH entry. Yes, okay. So that's why things were busted before. We were just loading the document for like the browser Chrome and stuff. I got ahead of myself. So did we get a doc shell ID? Yes. So there is a cache entry, or like we have a session history entry, and it knows about a doc shell. So pull it together, buddy. Come on. There's no previous viewer. That's how it worked last time. We get the old entry. Old entry exists, right? No. So that doesn't exist. I don't know if it's supposed to. If it is, that's a problem. I know we avoided that last time. Okay. And now let's fast forward. In here. Fast forward again. So, what do we have here? Do we have MLSHE? We do. Do we have MOSHE? We do not. I'm pretty sure that was the case last time, too. Okay, P cache key is null in this case. We tried to get a cache key, and we didn't get one. That's interesting. I have a feeling that that's not the case, that we do get a cache key back in the in the single process case. Yeah, I seem to recall us entering this block before. That's why I set a breakpoint, and we skip right over it. And we skip right over it again. Okay, so that's, I think, the problem, is that for some reason we cannot get a cache key from MLSHE, which I believe we do in the good case. Now, what is MLSHE? That's something I seem to recall from my notes. Yeah, what is MLSHE? This is why you take notes. It's a history. It's a reference to the NSI SH entry for this doc shell until the page is loaded. So it's the loading session history entry. The loading session history entry. When does that get set? Like, why can't we get the cache key? Is this the entry that I had originally passed? So the SH entry has this address 01219F9E20. Is that the same thing as MLSHE? 1219F9E20. Right. So MLSHE gets assigned the value that I pass in as my page descriptor, or sorry, the SH entry that we pass in from JavaScript, and for some reason we can't get the cache key from it. I think that's the problem. I think that's the problem. I don't know why, but I think that's the problem. So let's verify. Let's verify that we get a cache key in the good case. I'm pretty sure that's the case, but I want to verify. So I'm going to skip past a whole bunch of these breakpoints because we're going to be hitting them as we load the window up again. I've got half an hour. I really want to solve this mystery. Right, okay. So just continue. Don't care. Continue. Don't care. Don't care. Yes, now we care. We care now. Load history entry. Right. Cache key. And then we get the cache key. And what is the cache key? It is a thing. Okay, so we have the cause, I'm pretty sure. So the problem appears to be in where? Where are we? We are in, oh, this massive method. What are you called? NS doc shell do URI load. This particularly here, and now lovely Xcode formatting. I can just copy and paste, and I get some nice formatting there. The cache key is defined properly in single process mode, but in the content process, when I try to load the source, it is null pointer. Why is that? Okay, so we have figured out, well, I guess we haven't exactly figured out why we're still hitting the network, but I'm going to rephrase this to find out. Well, no, we have figured out why we're not hitting the network. I'm pretty sure it's because the cache key is null. So the next question is, why is the cache key null? in the content process case. So now we have to answer that question. And I've got half an hour to do it. Can I do it? Can I do it? Let me just slam back some caffeine, and let's give it a shot. Okay, so a bunch of these breakpoints that I just set up, I think we can clear them out. I don't think we need them anymore. I do want to keep this one. This one's particularly important. So I'm going to shut off the ones. How do I shut them off? There is a way. There is a way of turning off all breakpoints, but I don't know what it is. Disable breakpoints. Boom. And then I'm just going to turn on the one that I cared about, which I've lost now. Where it was in, what? Do URI load? Yeah, this one. Okay. So I'm going to enter this get cache key thing and figure out why it's blank. Like, what's your deal, buddy? And I was hitting a breakpoint there as well because I think I have some ones in LLDB. Xcode and LLDB seem to have like their own lists of breakpoints that I hit, and it keeps them separate. No, I'm still not. Am I good? Yeah. All right. So let's look at the bad case again. I don't want to close any of these for fear of crashing the content process. So the bad case. OpenView source. Hitting my breakpoint. Okay, so now I want to find out. I'm going to enter get cache key. Blah, 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 xpcom and gecko c stuff. This is all just like glue, add ref glue. Don't worry about it. It's very scary. I know. I'm scared. Get cache key. Here we go. So we get it from this shared thing. M shared M cache key. What is M shared? What is M shared? M shared is this SH entry shared. I don't know what that means, but it also has a cache key that is null. Why is that? No idea. No idea. But that's the problem, I think. Now, what if no, I don't. Now I have to figure out why. Okay, so let me copy and paste this into my notes. So what is M shared and why doesn't it have a cache key is the mystery. Is the mystery. I've got 27 minutes to solve a mystery. Can I do it? Can I do it? I don't know. I don't know, but let's find out. So I'm going to disable this breakpoint. I don't need that anymore. This is one of those LLDB ones. Break, delete, 2.1. Break, delete 2. Yeah, there we go. Great. So now I want to add a breakpoint. Sorry, I want to add a breakpoint in the parent process for the good case. So hang on, let me pause again and let's set a breakpoint. But we'll do it in LLDB. Or no, we'll just enter again. We'll go through all that goop and then we'll enter the break. We'll add the breakpoint next code. Is what we'll do. That is the plan. Okay, so we want the good case, which is this one. Boom. Hit my breakpoint. I hit my breakpoint, and now I'm going to enter this crap here. Pardon my language. Get the cache key, get the cache key. blah, blah, blah. Bunch of gecko C nonsense. And then here we go. Here's the important part where I will set a breakpoint. And M shared in this case, does it have a cache key? Well, probably it does. Yes, it does. Now, why does this one have a cache key and the other one does not, is the question. It's an HTTP channel cache key. Does the content process never get these? Is it possible that the content process never gets an NS HTTP channel cache key? Because if it doesn't, then my whole plan of like loading the source in the content process using a remote browser, it kind of explodes. Like it doesn't work unless I'm somehow able to get the cache key from the content process, send it to the parent, or sorry, get the cache key from the parent, from the, like, map the SH entry from the child to a cache key in the parent somehow. I don't even know if that's possible. And then maybe load a non-remote browser. Who knows? So I have to know more about this M shared business. And SH, when does M shared get set, for example? It's here, adopt BF cache entry. Shares document with. That's just checking equality. Here, abandon BF cache entry. And here, we just like create one that I guess is blank. What is that? Is that defined in here? So there's a header file. Let's check it out. A document may have multiple SH entries, either due to hash navigations or calls to history push state. Okay, that makes sense. SH entries corresponding to the same document share many members. In particular, they share state related to the back-forward cache. So NS entry shared is the vehicle for this sharing. I see. I see. I think I see. Cache key. So where does this come from? So let's take a look at the implementation. Cache key equals, here is whenever it happens when we duplicate an entry. So hypothesis, in the single process case, we duplicate a cache key. We duplicate a BF cache entry. Wait, I should use the right terminology. And NSSH entry shared entry. In the content process, we do not. Alternatively, here's an alternative hypothesis. We duplicate an NSSH entry shared entry, but that entry does not have a cache key. These are our two hypotheses. That's all I got. Let's see which one, if any, are true. Maybe they're both true, maybe just one. No, they can't both be true, but let's see which one, if either, is true. So what I will do is I will set a breakpoint inside duplicate, I guess. Duplicate. No, I'm in the wrong file. NSSH entry shared. Doesn't know about it. This is, so I hate this part. I want to like load this source inside Xcode because I want to add the breakpoint inside Xcode. I'm in a hurry. I'm in a hurry. And this is all out of order. by name. Mozilla Central, and where is it? It's under. Where is SSH entry shared? It's under doc shell sh s history doc shell history source shared. Now if I drag that into Xcode, I think it will load the source. That was probably a super inefficient. No, it did not. What if I just drop it on the Chrome? No. Come on. I don't have time for this. Just open the file. Ugh. Okay, then let's not waste any more time. We'll do it in LLDB. NSSH entry shared. Duplicate. Good. Okay, so set. So let's do the good case. The good case is here. I don't. Okay, we are here. So we did enter here. Now I will set the breakpoint in Xcode, and I will delete break delete 12. And then we do set a cache key because the entry has a cache key, right? Entry cache key. Where is it? Cache key. Yes, it has one. So that's why that works. And we skip over the other things. I guess we don't need that breakpoint anymore. Break, delete, 4. And that's why that works. And now for the broken case. Let's check the broken case. So much rotten poetry. Okay, here we go. Broken case. Broken case. So we hit my breakpoint. So we do duplicate it. So this first hypothesis is false. We do duplicate an SSH entry shared entry because we do enter the method. So my other hypothesis is that it doesn't have a cache key, the one that we've passed in here. And that is true. So that is true. The passed in NSSH entry shared has no cache key. So that's why. So that's why the cache key is null pointer in the content process case. But why doesn't the NSSH entry shared have a cache key when passed to SSH entry shared duplicate? So let's answer that question now. I've got a little bit of time. When is a cache key ever set is the question, I think. So like mcache key. There is a get cache key and a set cache key. And who calls set cache key? In doc shell, all of these things call set cache key. Well, all of these things in here call set cache key. Oh, I'm looking this up in the. I'm not using. Yeah, okay, sorry. I thought I was using the debug browser. And I'm like, that's going to take forever. So now where are we? What is this method? In internal load, we set a cache key here, 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 and here. This looks familiar. Well, so let's see which one of these we happen to be skipping. Um, hmm. Okay, so I have hypothesis. And as doc shell never calls uh, set cache key on the past on the NSSH entry that is eventually passed in to the is eventually passed into the view source window. So in order to track that, I think I have to actually do the post again in order to get like a new page. Like I need to exercise the bits that um, might set the cache key, and I think that only occurs once I've done the request. I think I have to do the request all over again. So let's continue. Then let's go inside doc shell here, and let's find all the places where we say set cache key, and we're just going to put breakpoints on all of them. I'm going to put breakpoints on every single one. On anything that ever calls cache key, set cache key ever. So that's all of them. Now in the good case, let's do the good case and see which ones of those we hit, and then in the bad case we'll see if we skip or if we do a different one maybe. So let's choose the right window. That's not this one, it's this one. There's so many windows that I don't want to close. Okay, that's just broken. Here we go. So I'm going to go back. Did I already hit it? I did. Just continue. And then we set a cache key. Interesting, interesting. Okay, so now I'm going to hit groove. And then we hit this here. I don't know if there's going to be a cache key. Let's find out. Is there a cache key? There happens to be one. Interesting. Okay. So we get a cache key. We post some stuff. We get it a bunch of times. Okay, and then we're done. And now I'm going to view the source. Do we set the cache key ever? No, we do not. Okay. But we get it a whole bunch. Okay, so in the E10S case, I'm going to go back. Going back, there seem to be never any cache keys ever, is what I've just noticed. We're hitting that a lot. Okay, and now I'm going to hit groove again. And we never did the part where we set a cache key. Okay, but we get. We just get. That's very interesting. So where was that one part where we did set one? Why don't we enter that case? Oh, did I even... Yeah, I don't think it's worth attempting... Well, I can try. Let's see. Yeah, we do the duplication, but there's no cache key. I know that already. I've learned. Okay. So the question is, where was that one place I failed to note where that one place was where we set the cache key. You know what I should have done was, instead of setting a breakpoint on all those points, I should have just set a breakpoint right here, and that's what I'm gonna do. I'm gonna disable the rest of them, or whenever I see them, I will disable them. Okay, so continue, continue. I actually don't think we need that anymore for now. I'm really interested in this bit, set cache key. So we never called it? That's interesting. I'm gonna get rid of that one too. Now we call it here. Where did it get a cache key from? HTTP channel. Is it possible that there just is no HTTP channel in the content process? I forget how networking works in E10S, but that might be the problem. Networking might all happen sent through the parent. So let's see that again. Do we have an HTTP channel? We do. How about in the bad case? Do we have an HTTP channel? We do. Okay. So that's good. And then I'm gonna hit groove. Do we have it now? Do we have it? We do. Great. Now, why do we never... It's circular. Like, we never set the cache key because we never get the cache key. This is where we were looking before. So the reason it's not set is because we never got it. So there's like some bootstrapping thing where at one point we set it and then we just keep like passing it around. And I need to figure out where we first call it. Okay, so thinking. Thinking, 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 thinking. Thinking, thinking, thinking. Okay, here's what I'm going to do. I'm going to shut down. I'm going to shut down the content. I'm going to shut down both processes. I'm just going to quit the browser. I'm going to restart the browser. Attach the debugger to the parent process and see when set cache key gets called. Is my plan. So shutting down, shutting down, shutting down. My meeting starts in like 7 minutes, 6 minutes. So gotta get moving. Okay, shuts down. So now, run again. That's the parent process, so I'll attach to that. And hopefully we capture a point where we call set cache key. What I'm going to PHP channel is null, so we don't enter this block, right? Again, null. Okay, so load up the browser. Load up the browser. You know, I'm just going to get rid of that. Don't need it. What I really need is to load this document in a non-ETNS window and figure out if and when it ever sets the cache key. If it does, I have to figure out why the content process doesn't do the same thing, because it looks like the content process also has an HTTP channel. So what the dealio? And why is the content process taking its sweet time starting up? Come on. It really took a long time. So I'll load the page in a non-ETNS window, and hopefully we will call set cache key. Come on. We never called set cache key. What? Do I even have... That can't be right. That can't be right. We must have done that wrong, because the cache key is defined here, so I must have done that wrong. Like, I do have set cache key. It's here. Is there another way that a cache key can be set without calling set cache key? Cache key equals under create. Create. Okay. Well, let's try that again. So play. That's my alarm because I have to go to my meeting soon, but I am determined to solve this mystery. So let's try that again. Gonna go back. And we do this stuff that I don't care about right now. And now I'm going to hit groove again. Do we create? Yeah, we create, and we are past a cache key. We are past a cache key. And we are called from add to session history. Add to session history. That sounds really familiar. Where? On new URI, on loading site, on new URI, we say create an entry, and the cache key is set from where? Where do you come from, cache key? Where do you come from? It must be defined in here. Where are you gonna be? Where are you at? Cache key, we create one. Or we create a pointer, and then we must get it from somewhere. Here, get cache key. If cache channel, if there is a caching channel. So maybe the channel is not caching. That's a possibility. And then that explains it. Like we cannot get a cache key if it's not a caching channel. So let's go back here in the content process case. I will attach the content process. Okay, and now I will hit groove and let's see what happens. So, do we have a cache channel? We do not. So that's what's up. Like there is no cache channel, so we can't get a cache key. The channel that we have been passed, this HTTP channel child, is not a caching channel. It does not implement the NSI, NSI caching channel. So let's write that down. the problem, this hypothesis was false. We do call, or that's actually true, but that's also true for the single process case. The problem is in creation. So I'm going to copy this block of code. Where are we? We are inside ns-doc shell in ns-doc shell. Okay, and I've got to go to my meeting. So I'm going to add this to my notes, this bit, and then I have to run off to my meeting. So I think we discovered some stuff. I think that was useful. Like, I know now why we're not getting the content out of the cache, is because in the child the cache key doesn't exist, and the cache key doesn't exist because the HTTP channel that we're using to communicate is not a caching channel, and that's the problem. So we have figured it out. Now the question is, well, what do we do about it? And that's something we will ask maybe some networking people next week when the Joy of Coding episode 11 airs. So thank you so much for watching this episode. I'm sorry to cut it short. We got pretty far. I'm pretty happy about that. Thank you for watching this episode. And next Wednesday, let's figure out what we're gonna do. So thanks for watching. Take care, and see you next week.